Looking at section 1.3, algebraic expressions. It says, how do you evaluate algebraic expressions? How do you simplify algebraic expressions? Again, some Algebra 1 review concepts. So example 1, modeling words with an algebraic expression. It says, which algebraic expression models the word phrase 1 less than twice the product of 6 and W? So we had to go through and identify some of those words that tell us what operation to use. So one of those I see is the phrase less than. And I know that less than in this case means that we are using a subtraction. If it said is less than, we'd be looking at that inequality type sign. But less than means to subtract. Less than also tells us we need to flip-flop the order of that subtraction. So we are going to end up taking 1 away from something. So we need to have a minus 1. 1 less than 1 subtracted from what? It says the product of 6 and W. Well, product means that we are multiplying. The and tells you where to put that multiplication sign. So we have a 6 that's going to multiply with W that's going to go in the front here. So that means I'm going to have a 6W minus 1. It says to model a situation with an algebraic expression, do the following. Identify the actions that suggest operations, kind of looking for those clue words. It says to define one or more variables to represent the unknown or the unknowns. So maybe you are trying to find how many hours or how much money, being able to turn that word into a variable to use. And then represent the action using the variables and the operations. So let's try one. Example 2. It says you are on a bicycle trip. You traveled 52 miles the first day. Since then, your average rate has been 12 miles per hour. Write an algebraic expression to model the distance you have traveled so far. So we already know that you have traveled 52 miles. And you are going to travel at an average rate, which is 12 miles per hour. So we have 52 and means that we're going to add with that 12 miles per hour. What does this word per tell us to do? Is that adding, subtracting, multiplying, or dividing? Well, in this case, it means we're going to multiply. So if we write an algebraic expression, we have 52 that we're going to add with 12 miles per hour. Well, I don't know how many hours, which means I need a variable to represent hours. I kind of like the letter H in this case because H and hours kind of goes together. If you want to pick a different variable, be my guest, but make sure you define your variable. So we're going to say that H is equal to the number of hours since the first day. The next part talks about evaluating an algebraic expression. Evaluate just means to solve. So when we're dealing with algebraic expressions, algebraic means we're dealing with variables. They want you to substitute the number for each variable in the expression, then simplify using the order of operations. So example 3, again, algebra 1, maybe even some pre-algebra stuff here. All right, we're going to take out variables and plug in some numbers and do some order of operations. So I'm going to zoom in here a little bit. If I have r is equal to 3, wherever I see an r, I'm going to replace it with 3. So we have 2 times 3 plus 5 times, in place of s, they tell us we have a negative 9 plus 6 and a minus 1. Some order of operations, I see some parentheses that need to be taken care of. So that means I'm going to have negative 9 added with 6 gives us a negative 3. I take care of parentheses. I don't see any exponents, which means we need to multiply or divide next. So I have some multiplications. So that means I'm going to have a 6 plus, that's going to give us a negative 15 and a minus 1. And then I'm down to just combining with addition, and subtraction. 6 plus a negative 15, so 6 minus 15, that would take us to a negative 9. Negative 9 minus 1 would take us to a negative 10. If I look at part B, we have C as 1/4 and D as 1. I'm going to zoom in so we can see a little bit better. So if I take out C, I plug in 1/4. So we have a 1/4 that's going to be raised to the third power. We're going to subtract D, which is 1/8. So 1/4 to the third power, I'm going to do a little side work. That's a 1/4 times a 1/4 times a 1/4. 1 times 1 times 1 on the top is 1. 4 times 4 is 16. 16 times 4 is going to give us 64. So this right here is going to give us a 1/64, that we have to take away a 1/8. Little bit of fraction work. You guys can do this. You don't need the calculator. What do we need when we are subtracting fractions? You need a common denominator. In this case, what's going to be our common denominator? Should be pretty obvious, 64, right? So 1/64 stays the same. 8 times 8 is 64, so 1 times 8 is 8. And if I take a 1/64 and I take away an 8/64, we end up with a -7/64. If you can't do that basic math, we should probably talk. Okay? All right. If I ever go too fast, please feel free to pause the video and catch up. Example 4 says writing and evaluating an expression. Tickets for admission to a museum are $8 for adults, $5 for children, and $6 for seniors. Write an algebraic expression that models the total number of dollars collected in ticket sales. Well, we have 3 unknowns: how many adults, how many children, and how many seniors. So I'm going to take a moment. I'm going to say I'm going to use A to represent the adults. I'm going to use C to represent the children. And I'm going to use S to represent the seniors. Once I'm able to identify my 3 variables, I have 8 for each adult. That means I'm going to take 8 and multiply it by the number of adults. I'm going to take 5 and multiply it by the number of children. And I'm going to take 6 and multiply it by the number of seniors. It then tells us if 20 adult tickets, 16 children's tickets, and 10 senior tickets are sold one morning, how much money is collected? So we take out those variables and we plug it in. So in place of A, we have 20. So we're going to have an 8 times 20 plus 5 times we have 16 children plus 6 times we got 10 seniors. 8 times 20, 160. 5 times 16, 80. 6 times 10, 60. So 160 and 80 is 240. 240 plus 60, that's going to give us an even 300. Since we're talking money, go ahead and throw a $sign in there. And please make sure that you're smarter than all the people on social media that put the $sign at the end of it because they read it as $300. The $sign goes in front when you're using it as a symbol. The word dollars is written out after the number, right? So just be smarter than some of the other people around us. All right, some more terms and definitions to kind of look at. Again, some pre-algebra kind of concepts. A term is an expression that is a number, a variable, or the product of a number and one or more variables. A coefficient is the numerical factor of a term. So for instance, the coefficient, they're pointing over here, coefficient would be a number that's being multiplied with something. So in that case, that coefficient is a -4, the coefficient of 7, right? Those would be the coefficients. Now terms would be each of those things, right? That -4ax is a term. The 7w is a term. The -6 is a term. And then the last one talks about the constant term. Constant, if something is constant or consistent, it is what you expect it to be. It's not changing in any way. So that is a term with no variable. So that's where they have that -6 at the end there is a constant. Like terms have the same variable raised to the same power. Right? I think you guys already know some like term stuff. And then a few more definitions or some of the properties when simplifying some algebraic expressions. Run through it quickly, and then last example. Definition of subtraction. If you have an A minus B, you can turn that into an A plus the opposite of B. Anytime I taught integer rules, if I had something that was a 5 minus 7, I would have my students take and add the opposite. So they would have a 5 plus a negative 7, which helped them visualize that a little bit easier. If you like it, use it. If not, just understand that it is a true statement. Definition of division: if I have an a divided by b, that means I can put a over top of b, or a times that reciprocal 1 over b. Again, b cannot be equal to 0. We cannot divide by 0 parts. Our distributive property of subtraction, right? You remember the distributive property, multiply what's on the outside in. Multiplication by 0, anything times 0 is 0. Multiplication by negative 1, it turns that whole thing into a negative. 1 negative makes that whole term negative. It says the opposite of a sum. Again, that's the distributive property. You're giving the opposite of that, changes those signs on the inside. The opposite of a difference, again, a distributive property, it changes the signs. The opposite of a product. So if you have a negative times AB, one negative is going to make that whole thing negative. And it doesn't really matter which one is going to be negative. Either you can make the A negative or the B negative, but not both. If you made both of them negative, you'd have two negatives, which is a positive. Just like the opposite of an opposite, a negative negative A means that you have a positive A. Two wrongs don't make a right, but two negatives make a positive. And last quick example, this all should have been pretty review stuff. Combine like terms. So if we have a 2a squared plus a 3b squared plus a 6b squared plus a 5a squared, what are our like terms? Well, I have a 2a squared and I have a positive 6b squared. I don't want that together. I want the a squared, right? 2a squared plus 5a squared is going to give us a 7a squared. If I have a 3b squared and a 6b squared, those are alike. I get 9b squared. My exponent does not change when I'm adding. I had 2 of those things and 5 of those things. I have 7 of those things. I had 3 of those things and 6 of those things. I have 9 of those things. Those things don't change. That would only change if you were doing some sort of multiplication between those. If I were to look at part B, we have a negative on the outside, which means that we would want to distribute that in. So we'd have a negative x and a minus 4y. We have a 5 on the outside. We want to distribute that in. We'd have a positive 15x and a minus 5y. And then we would look for some of those like terms. I have a negative x and a positive 15y. That's going to give us a 14x. I have a negative 4y. I have a negative 5y, which gives us a negative or a minus 9y.